Welcome to Medical School Companion. Our lesson for today is going to be an overview of the immune response. I think you'll find as you study these subsequent lessons that the immune response can get fairly hairy fairly fast. And so I always like to start with an overview of the entire system in a very bare bones or skeleton type approach, so that you can start lodging in your mind indelibly the fact that the engineering design of the system will always give you information that will be useful as you are managing patients in your day-to-day practice. The immune response is extremely complex, but most logical designs will talk about the difference between the innate system and the acquired system. The innate system existing as a barrier that is designed to keep things from happening in the body and getting into the organism as a whole. So you can think of your skin as a barrier, you can think of the chemicals in your stomach, the pH of your stomach as being a barrier. You can think of your mucosal surfaces being a barrier between yourself and the outside world. Now, the whole system is designed to work as a whole. It's not designed to work piecemeal in such a way that you either have something happening innately or you have something happening adaptively. But that said, you can divide the two logically by thinking about the timing in which they will occur in the patient. Because if I think of a set of characteristics which are present in my body at all times and are either nearby and enter to be activated, or they're in a situation where they can immediately be activated by some sort of injury, then you realize that the innate system is the first responding system that is going to be responsible for the fact that you stop things from getting any further, if that is your goal. Now, the adaptive portion of the immune response is the one that takes time to develop. And so constantly, as you are thinking about a patient in your office and imagining what is going on in their body that is giving them the set of symptoms and signs that you will evaluate, knowing the timing under which something has happened in their body is going to be very important for you to realize whether it was something that was a barrier system that was being occupied and activated, or is it something that is going to take some time and some signaling and some recognition and some development of processes within cells and tissues. Now, the entire system is designed to evaluate the difference between self and non-self, because intuitively, I think you can imagine that your body does not want to identify your own tissues as invaders or aliens, but it must have a very strong ability to evaluate those things that are introduced into your body following some injury or some invasion. And so the recognition of those foreign things entering one's body is what sets off the signaling that we will talk about here soon. Now, the second portion of the immune response, the acquired, also known as the adaptive portion, is going to be activated after the barrier systems have been breached. It's not necessarily that they have failed, it's simply that something has entered the body by a means that gets it into one's deeper tissues, and now one needs to activate an immune response in order to get rid of that. In the case where we have the adaptive immune response called in, these cells that are involved are going to be intensely involved in signaling to one another through the production of chemicals or communication molecules that we refer to as cytokines. And cytokines will allow one cell to communicate with another that something injurious has happened, and I therefore need to start to turn on the more intellectual component of the immune response that is going to recognize things very specifically. Now, if you look at my next table here, notice that what I've done is I have divided the immune response very clear-cutly into two systems, innate and acquired. But I want you to remember when we look at our summary diagram here at the end of this chapter, that you will notice that Mother Nature did not design either of these systems to operate in a vacuum. They are designed to operate sequentially. And so if you can keep that engineering design in your mind, then you can be able to evaluate what actually is happening in your patient at any given moment after some injury. If you notice, the innate immune response is going to be peaking at very early periods of time after an injury, because these are the barriers and the chemicals and proteins that are present in an area or are brought in by very early events that we refer to as acute inflammation. If there are cells involved, they will be our white blood cells in the granulocyte lineage. Granulocytes have granular cytoplasm, and there are a number of these that are both resident throughout your body, immediately underneath the barrier systems, and then there are also lymphoid cells that fall into the category of operating innately. Of the chemicals that are involved in this early response, it's going to be things like the pH in an area that can immediately destroy some microbial agents, and it can be things like the skin pH or the stomach, any of those things where a actual environment causes the microbe or the injurious stimulus to be removed. Out of the category of proteins, we would have things like complement. We'll speak about this at length later on, but you should remember, even at this early stage, that complement is a set of inactive zymogenic proteins that activate one another in a sequential fashion and end with the function of causing the lysis of whatever those proteins have sequentially attached to. So they come in with the blood flow into the area. And I also have a category of interferons, which are cell-to-cell communication molecules, which function specifically against viral pathogens and act innately. They're not made in response to any particular stimulus. They're simply there, and they act to slow down a viral life cycle. Now, notice very importantly that one of the key things about the innate component of the immune response is that it has limited specificity and diversity due to the fact that it is designed to act as a barrier and recognize very highly evolutionarily conserved molecules found on the surface of things that man has evolved in the environment of. So in all of the many eons of evolution, there have been highly conserved molecules that are found on creatures other than ourselves. And so we have learned in this early system to recognize those invasive molecules and use them as the signal which will cause us to turn on an immune response. So we refer to these things as pattern recognitions. In other words, they are conserved evolutionary moieties that associate with something other than a human being. And so we have learned to recognize these as the first indication of some sort of invasion. Then when we talk about regulatory control, it's certainly not true that there is no regulatory control in the innate immune response, but it is much less significant than that in the response that evolves afterwards, because it purely is a function of the signaling from the invader or from the injury as to what is the extent of the damage that will continue to cause the chemicals and cells to come into the area. So it's driven by the invader and not necessarily by any communication from cells that are actually deciding what they're doing. As long as the invader remains there, the continued response of these sentinel types of cells and chemicals will continue. As far as memory is concerned, there is none in the innate immune response. By which I mean your skin doesn't get any stronger, your mucosa doesn't get any different. You do not develop other chemicals in your stomach or on your skin. These are things that are naturally there, and they do not amplify or increase in efficiency with time. Okay? Now contrast that with the acquired immune response, which, as I have been trying to emphasize, is something that is going to develop days to weeks after the immune response that we referred to as innate has done as much as it can. So if signaling in an area of injury or invasion continues, there will become time for cells to enter an area and communicate with one another in such a way that they can now say, okay, we're going to do a particular type of immune response in order to answer what we recognized was the specific problem here that occurred. So you'll notice now we've switched over into a different category of cells being responsible. And you're probably aware that lymphocytes are really the brains of your immune response, but you may not be aware that we now know that they come in multiple categories, and not all lymphocytes are going to act in an adaptive fashion. If you remember, we had some innate lymphocytes that acted as a component of the innate response to begin with. Now, the chemical signals that occur between cells, chemokines, are those things that will be released from one responding cell to communicate downstream to another cell that's now going to collaborate in removing this injurious stimulus, whatever it was. The proteins in this component of the immune response, we have antibodies, which we'll certainly spend a considerable amount of time on later on. But we have the other category of interferons, the type 2 interferons, which are for signaling between consenting adult lymphocytes, as it were. The specificity of the adaptive immune response is truly astounding. And it is estimated that every single human being can respond to millions of different, unique, three-dimensional shapes of invading molecules and very specifically respond to them in an appropriate way. So unlike those evolutionarily conserved patterns that have come to be clues of an invading microbial pathogen, every lymphocyte will develop a receptor that is specific for one very unique three-dimensional structure of the foreign substance, and that combining to its surface will start off a cascade of recognition and activation responses. Now, notice that the regulation of the adaptive immune response is truly profound, because not only does one cell communicate with the next in sequence, but there are feedback stimulations and also reciprocal inhibitions between these two cells. So you can imagine the adaptive immune response operating like a very, very finely tuned thermostat to turn up a response through communication and dampen it down when it's no longer necessary. So the greatest majority of the control of your immune response resides in the intellect of those adaptive lymphocytes. And this means that every single time you're exposed to something, your immune response will get both stronger and faster. And it truly is the only way that one can think about living a long, healthy life, by allowing your immune system to do its job. Because if you think about it, and I know that this may be an unpleasant thing to put in your mind, realize that building your immunological muscles through encouraging your lymphocytes to respond and activate and clone themselves is what protects you from the next exposure to that same thing. So that just as though you don't become this incredibly pumped bodybuilder by spending all day lying on your sofa and popping chocolates and watching soap operas, your immune response benefits from exposure to the environment. And the more exposure you have to your environment, the stronger your immunological muscles get, to the point that if you allow it to do its job, you will reach a point where you simply do not get sick very frequently because you have memory cells that recall seeing this particular material before. Now, when we put all of this together into a diagram, remember that I don't want you to focus now on the minutia of the system, because what the rest of our modules will do here is dissect the individual pieces and talk about them and their molecular detail. But if you always have the underpinning that you're building upon, that you understand that step one is followed by step two, and step two is followed by step three, not to make a bad pun about your testing, but still in the immune response to think about the fact that this is a sequential design of an engineer that causes you in a sequential fashion to make a response, evaluate how it worked, and then continue to evolve down more complicated responses as you move down the page. So notice here, without too much detail, that our initial response to any injury or to any invasion is the process that we refer to as acute inflammation. And acute inflammation is going to cause the infiltration of cells and proteins that are going to be important for an immediate or nearly immediate response to something that has been introduced into your body. So notice I've tried to indicate that I've got enlargement of the vascular channel happening in these cases that will allow the blood to flow in more aggressively and bring in both those cells and proteins. And then through a process, again, that we will talk about in detail, that's referred to as diapedesis, what we will do then is take those cells from the circulation at the point of injury and introduce them further deeper into the tissues so that they can respond to whatever has happened there. Now, you know that there are first responders that arrive very rapidly because they are numerous and would be found in that enlarged vascular channel. Neutrophils, or PMNs as we also call them, are key first responders, and they are cells that will come into an area, eat as much of a foreign substance as they can, because they're recognizing those patterns that we spoke about before. Those pattern recognition receptors that they have on their surface allows them to ingest and digest. And then, although it's not a very attractive thought, neutrophils in their final step of phagocytosis are often thought of as being bulimic because they eat as much as they can and then they explode. And that very act of explosion is going to contribute more toward the sterilization of the area from any microbial invader, because their vomit, as it were, is truly just a mass of acidic goo. So it is both their phagocytosis and their explosion that causes the production of a very important pathological lesion that you'll be speaking about in detail, and that is the formation of an abscess. What is an abscess? Well, it's an accumulation of dead and dying neutrophils and dead and dying microbes. So when that happens, it's doing the dual purpose of attempting to kill anything that has invaded, but it's also trying to wall it off and keep it from going further into your tissues. There are certainly occasions when that's all you need. That walling off, that Bulimia is going to stop the progression of the microbe any deeper. And although I have to have a mechanism of getting rid of the pus eventually, that may be all that's required, particularly when I have a scenario where what has invaded the location is an extracellular microbe. In other words, a microbe that's living outside of my cells in the fluids and spaces around the cell membranes. Now, if that is all that's necessary, it's still true that my next step in the progression is going to require cleaning up the debris, because remember, the neutrophils came and ate and exploded, and I've now got all of this debris in the area that I need to clean up. This is going to require a different category of phagocyte, and that category of phagocyte is what we're going to refer to as an antigen-presenting cell. Okay, remember, antigen is going to be that material that is recognized as being foreign by your immune response. And to say that something is capable of antigen presentation should intuitively, I think, imply to you that this has to be done by a cell that has a longer lifespan than simply to come and eat and explode in an area. So there are multiple different types of phagocytes. To phagocytize something simply means I eat it up. But my antigen-presenting phagocytes are those ones that have to be capable of then communicating downstream in the engineering diagram so that I can tell the cells beyond my presence what it is exactly that happened in that area. Now, my abbreviation here, APC, is going to refer to that category of phagocyte, which is usually going to be a resident cell. I could also refer to these as sentinels in my body because they are observing and they are communicating when there is something that has gotten into your tissues. And I've got different pathways that an antigen-presenting cell can evolve down to once that initial signal of phagocytosis has happened. They were called in order to eat the debris of what the phagocytes that are not antigen-presenting cells, like neutrophils, have done. And so they're going to evaluate that process and then communicate downstream to the next available cell. Now, again, we're doing this in a very superficial level now so that you just are thinking about the sequence of events. But suffice it to say for now that the antigen-presenting cell who comes in to clean up the mess is going to interpret what it was that actually caused the mess, and signaling from the debris of what the neutrophils left behind are going to be interpreted as to whether or not that material was extracellular or intracellular in its origin. That is a terribly important signal because remember, if you're thinking strategically about trying to destroy something that has invaded your body, there's going to be a very different recognition way if it's something that's just floating around in your tissue fluids versus something that is actually hiding inside your cells. Because in the latter case, if it is an alien internal invader, I have got to be able to recognize the difference between a normal cell of my body and a cell that has that alien hiding inside. And this is going to be the origin of the signaling that will cause my immune response to specialize into a response against extracellular things that will eventually evolve into production of antibodies, as you'll see shortly, or is it going to be something that evolves into a response that would be determined to identify the difference between an infected and an uninfected cell? Okay, now suffice it to say that we're not going to deal with the signaling now, other than the sequence. So my antigen-presenting cell receiving the signal of where the pathogen came from and what it was, is going to signal to my first lymphocyte in the adaptive response, my T helper. Now, you probably recognize these guys as being CD4 positive, and in later discussions, we'll talk about what those markers are on the surface of cells that we identify them with in a clinical setting. But a helper cell, I have always analogized to the general of your immunologic army. The general being the individual who is going to deliver the orders to the soldiers and the sailors and the Air Force crews that are going to carry out the actual destruction of the pathogen. So think of the general as receiving his initial signals as to what is going on by the sentinel cells at the area of the injury who have recognized whether it is an internal or an external invasion. Okay? If you want to go for a somewhat perhaps inappropriate analogy these days, you could think about the antigen presenting cell being the general's wife, because the general needs someone to tell him or her what is the case of the happening on the innate barrier system that has been breached. And because of the fact that he cannot be at the battle area immediately, he has to receive that intelligence from a sentinel cell who is telling him what's going on. So the spouse of the general, to be non-sexist, is the originator of the signaling. The general is going to make the decision of the orders that are going to be coming next. Now, depending on the signaling from the sentinel spouse, the general is further going to evolve down a pathway toward making different types of chemical signals. All of this communication between cells is happening by chemical signaling. And so the general, having listened to his wife, will now determine whether he needs to become a so-called specialized T helper 2 or a specialized T helper 1, which you can think of as the general of a very specific type of force. So one might be the general of the Army, one might be the general of the Navy, the Air Force, or whatever. And so the orders that originate from those specifically differentiated T helper cells now will flow out of their cytoplasmic membrane and communicate with the cells that we refer to as the effectors of your immune response. And that's a fancy word. It simply means these are the guys who are actually out there on the battlefield doing the killing. So on one side of the immune response, where I had my alternative antigen presenting cell talking to my T helper 2, my effectors on that side are going to be my cells who make antibodies. And antibodies are the basis of what we refer to as the humoral immune response. Now, taking this back to thinking logically, realize that if I make soluble protein molecules like antibodies, they would have the capacity to bind to a soluble microbial material or the cell itself and cause those things to be destroyed by phagocytosis or complement activation or whatever else. So it should, I think, be clear that if I have an extracellular invader, my best thing to do is to turn on the humoral immune response in order to get rid of it. And think about the fact that that is going to cause some feedback back to the initial site of injury, because the production of antibodies is going to enhance the capacity of your early phagocytic cells to do their job better. So we do have an amplifying loop. And if you recall, that process of amplification is referred to as opsonization. Opsonization is a word that's taken from the ancient Greek. And apparently, opsonos in Greek means gravy. So if you think about what antibodies do, they coat something that you're going to eat like gravy. And because they're now coated, you're going to eat that much more of them much more happily. So in the same sense that I would eat a lot more mashed potatoes with gravy on it, our neutrophils are going to eat a lot more bacteria if they're opsonized with antibodies. Now, on the cell-mediated side, notice that it was my antigen-presenting cell that was stimulated in a classical fashion that is going to send the signals to the T helper to become a T helper 1, who is going to become the general of the cell-mediated army. And each of the cells who are the effectors of the cell-mediated immune response have a very specific targeting system that allows them to identify what is the infected cell that's causing the problem. Remember that each one of those types of effectors is going to have the ability to do an incredibly fine discrimination between a normal cell of your body who's minding its own business and a cell who would like to mind its own business but has got an alien invader inside. So turning these effectors on have evolved over evolutionary time to be very specifically defined for different types of intracellular dwelling pathogens. Okay? Now, that just gives us an overview of what we will be doing in all of the rest of the modules here if you stick with me. But the point I want you now to engrave in your memory is that everything begins with inflammation. Signals from inflammation talk to my phagocytes. My phagocytes will eat as much as they can, and those who are capable of antigen presentation will send the message downstream to a T helper cell, who then becomes the source of all of the marshaling of the soldiers and the sailors and so forth, who will then come into the area and attempt to do their best to clean that material out of your body, whether it was something like a bacterium, whether it was a virus, whether it was a malignantly transformed cell. Thank you for listening, and I'll see you in the next module.